This is probably the best use of Squeeze Theorem. So we are given a limit, and limit of the since n is going to infinity, this is the infinite sum, right? And we want our limit as n goes to infinity. So even after you look at these problems in the denominator, because there are these numbers 1, 2 up to n with n cube, you might feel that those are insignificant because n is going to infinity. And so n cube is way bigger, right? So if you just use that logic, you will be able to uh, reach the solution, right? Because you can just ignore those numbers since n cube is way bigger when n goes to infinity, right? So if you just use this idea, you will be able to find the answer. But we need to be a bit rigorous, right? We need to be a bit, we cannot just, use your intuition only. You need to be formal, right? So we'll also see how we do by being a bit rigorous. Okay, so let me just complete this solution. So basically, first of all, I took the denominator common, and then after that, I took n common. And now we can just use the formula for sum of natural numbers, which is n into n plus 1 by 2, right? Now at infinity, all these n and n plus 1 are same. So this is just n cube by n cube, and that gets cancelled out, which gives half, right? So this is the answer. It's easy to get it. But now, just to be rigorous, now we say that this sum even over here, because it has some numbers denominator, but this doesn't have those numbers, this one will be bigger, right? Because the denominator is smaller, so the whole thing is bigger. And you might say that it's strictly bigger, but as limit n goes to infinity, there's chance it can be equal, right? Because at infinity, all of these can just be 0, all of this can just be 0, right? And so they're equal. No, it's not really all of them can be 0, but their sum might not be 0. So yeah, the thing is, they might be equal at infinity. Now similarly, we can let's say this, if our required limit is s, what do I give the name? If let's say if this such l, then we knew that l is less than this, so half, right? So now we can also show that l is bigger than equals to, instead of 1, 2, we can just take n now. That gives us 1 by n cube plus n, here limit n goes to infinity, plus 2n by n cube plus n up to n square by n cube plus n, right? And this gives us limit n goes to infinity of, here we have sum. I can basically take the denominator common because we have the same denominator, and this is just the same sum again, right? And this gives us limit n goes to infinity of n into, now again sum of natural numbers is n plus 1 by 2, right? And over here this is just n times n square plus 1, right? So n square plus 1 is just n square at infinity. N plus 1 is just n, right? At infinity, this numbers plus 1 plus 2 doesn't matter. So n square cancels with n square, n cancels with n, and we just have half again, right? So yeah, you see, so from here, we see that L is also less than equals to half, but also greater than equals to half. So this implies by Squeeze theorem, that L is actually half. And this is how you might want to formally prove this. Okay, so we have already a solution, but I just want to show you how this can be solved also by using the Riemann sum, right? That's also a really good practice. This is also solvable using the Riemann sum, So n by n cube plus 1 plus 2n by n cube plus 2 up to n square by n cube plus n, right? So we can write this sum as sum n goes to infinity, sum from k is equals to 1 to n of kn by n cube plus k, right? Now to make a Riemann sum, what we do is we will introduce a 1 by n over here, right? And that makes it 1 by n square. by n cube plus k, right? Now we will divide both numerator and denominator by n cube. That makes it k by just n divided by 1 plus k by just n, and then 1 by n square, and then 1 by n, right? Know that this 1 by n is 1 minus 0 by n, and this is basically our limits of integral. So we see that if we just try to convert this now to integral, we will have 1 by 1 plus x by n square times dx, right? Yeah, but over here, since n is going to infinity, this term will just go to 0, right? So basically, if we convert it to integral, we will have integral from 0 to 1, and then x by 1 plus 0 dx, right? So because of that, now we have integral from 0 to 1 of x dx, and this becomes x squared by 2 from 0 to 1, and that's just half minus 0, which is half. So anyway, we get the same answer. So yeah, this was an extra thing like to share. And I do hope you get the idea of how Squeeze Theorem worked. And like instead of n cube, you could have made it n cube plus 1, n cube plus 1. That would have also give the same solution, right? It doesn't really matter. Yeah, so we have solved this problem. I hope this made sense to you, and I hope you enjoyed the video. Thanks for watching, and I look forward to seeing you in the upcoming videos too.